In this video, we'll discuss acid-base titrations. So let's start off with a question. If you're in the lab and you see a bottle labeled HCl, hydrochloric acid, but it doesn't tell you how strong it is, doesn't tell you the concentration, doesn't tell you the molarity, doesn't tell you the percentage, how can you determine how strong that acid actually is? So the answer to that is to use an acid-base titration. And so let's look at an example. In this flask, we're going to pretend that we have an acid. We're going to pretend that we have hydrochloric acid, and we know the volume, but we don't know the concentration. So we will set up an apparatus like this with a flask, a burette. The burette is kind of like a long pipette, but with a little valve. And so we have the acid of unknown concentration in the flask, and then we add a base of known concentration. So let's say that we have 1 molar sodium hydroxide. So if we add our known concentration of a base into this burette, we can turn the valve and 1 drop at a time will come through. Drop, 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 drop. And we keep doing that until we have equal parts acid and equal parts base in this flask. We just keep doing it until they're equal parts acid, equal parts base. Because if we know how much acid we put in, if we know how much base we put in, we know the concentration of the acid. And so when they are equal, that's called the equivalence point. So that means for every OH negative in that solution, you have an H plus positive, and then they come together and they make water. When that happens, the pH changes to 7. And so we will use a chemical called an indicator that will tell us when we get to 7. The way this is done is through a neutralization reaction. And that's a reaction between an acid and a base, and it produces salt and water. The H positive from the acid combines with the OH negative from the base, and together that makes water. The indicator is the chemical that tells us when we're at the equivalence point, and the equivalence point is where the pH is neutral. In the lab that we're going to do, we will use phenolphthalein, which is really neat because it turns pink. And so now once you've added a certain volume of that base to your unknown acid, we will use this equation to solve for the molarity of the acid. So we're solving for MA. MA is the molarity of the acid, VA is the volume of the acid, MB is the molarity of the base, and VB is the volume of the base. So let's look at this example. It takes 83 milliliters of 0.45 molar sodium hydroxide to neutralize 235 milliliters of NH hydrochloric acid solution. What is the concentration of the acid, the hydrochloric acid? So we have our MB, which is 0.45 molar. We have our VB, which is 83 milliliters, and then we have the volume of the acid, which is 235 milliliters. Of course, we're looking for MA, which is the molarity of the acid. And our equation, once we have isolated the variable that we're looking for, is MA equals MB times VB divided by VA. Substitute your numbers into the equation. MB, VB, VA. Multiply these two, and then divide by 235. When you do that, you get 0.16 molar. That's all there is to it. If you use the guess method, this will be very, very easy. All right, here are 4 practice problems. I want you to solve these problems on your own, and then once you've completed these problems, show me that you've done the problem, show me your work, and then I'll check you off, and then you'll be ready to do the lab tomorrow.